Welcome to Shri Learning Academy. Let's simplify processes in operating system. To understand what a process is, let us start with something very familiar. Imagine you double click on a music player app. The app opens, plays songs, responds when you pause or change tracks, and then closes when you exit. All of this activity is not just the program sitting on your disk, it is the program in action. In operating system terms, that program in action is called a process. So, in simple words, a process is a program that is currently being executed. A program by itself is just a set of instructions stored on the hard disk. It is passive. It does nothing until the operating system loads it into memory and starts executing its instructions. Once that happens, it becomes active and we call it a process. Think of a recipe written in a cookbook. The recipe itself is like a program. It tells you what to do step by step. But the moment you start cooking by following that recipe, chopping vegetables, heating the pan, and mixing ingredients, that activity is like a process. The recipe is static, but cooking is dynamic. In the same way, a program is static, but a process is dynamic. Now, let us connect this with what we already learned earlier about system components. We mentioned that process management is one of the core responsibilities of an operating system. This is because a computer usually runs many processes at the same time. Even when you think you are doing only one thing, like typing in a document, there are many background processes running. The operating system itself runs processes, the file system runs processes, network services run processes. All of these need to be managed carefully. When a process is created, the operating system gives it certain resources. These include memory to store its code and data, CPU time to execute instructions, and access to files or devices if needed. The operating system keeps track of all this information so that processes do not interfere with each other. Let us take a simple example. Suppose you open web browser and then open a text editor. These are two different programs. When you open them, the operating system creates two separate processes. Each process has its own memory space. This means the browser cannot accidentally override the memory used by the text editor. This separation is very important for system stability and security. Now imagine opening two browser windows. Even though it is the same program, the operating system can create multiple processes for it. Each browser window may run as a separate process. This shows that a process is not just about the program name. It is about an instance of a program in execution. A process also has a life cycle. It does not exist forever. It is created, it runs, and then it ends. We will study process states and transitions in detail later, but for now, it is enough to know that a process goes through different phases during its lifetime. Sometimes it is ready to run, sometimes it is actually running on the CPU, and sometimes it is waiting for something like user input or data from the disk. Another important idea related to a process is that it contains more than just code. A process includes the program instructions, the current values of variables, the memory stack, and information about which instruction is being executed right now. It also includes details like open files and network connections. All of this together forms a complete picture of a process. To make this easier to imagine, think of a student writing an exam. The question paper is like the program. The student actually answering the questions is like the process. The answer sheet, rough work, pen, and the time given to the student are like the resources allocated to the process. Two students may have the same question paper, but their answer speed and progress are different. Similarly, two processes of the same program can behave differently. Now, let us talk briefly about how the operating system keeps track of processes. Internally, the OS maintains records for each process. This record contains details like the process ID, which is a unique number given to each process, its current state, and information about memory and CPU usage. We will explore this structure later when we discuss the process control block. For now, just remember that the OS always knows which processes exist and what they are doing. One very interesting thing about processes is that they give the illusion of parallel execution. In a system with a single CPU core, only one process can actually run at a time. But the operating system switches between processes very quickly. This is called multitasking. Because the switching happens so fast, it feels like multiple processes are running at the same time. We will later study context switching and scheduling to understand how this works in detail. Processes also play a key role in protection and security. Since each process has its own memory space, one faulty or malicious process cannot easily harm others. If one process crashes, it does not usually bring down the entire system. This isolation is one of the reasons modern operating systems are more stable than older ones. It is also important to understand that processes are heavier than threads, which we will study in the next module. A process has its own memory and resources, while threads share resources within a process. For now, just keep in mind that processes are the basic unit of execution and resource allocation in an operating system. In summary, a process is a running instance of a program. It is active, dynamic, and managed by the operating system. It has its own memory, uses CPU time, and interacts with other system components through system calls, which we discussed earlier. Without processes, an operating system would not be able to run applications, manage multitasking, or provide a smooth user experience. Understanding processes is the foundation for learning scheduling, synchronization, deadlocks, and many other important operating system concepts that we will explore in the upcoming topics. That is it for this video. See you in the next one.